how to do a DNS lookup in Node.js inside your Kubernetes cluster for targeting specific pods. I'll give you the short explanation first, and then we'll dive deeper into all the configuration and the YAML files and why you might want to do this. Okay, so quick and dirty, if you just want to do a DNS lookup, you're going to use the DNS package that is part of Node.js. So you just require node:DNS. It's just something that comes with Node that's built in. And the configuration would look like this. You put your headless service as the first argument, set all to true, and then you'll get a console log of your addresses back in an array of objects that looks like this. Okay. So why might you want to do this and how could you configure it? Well, for my example here, I've got like a MMORPG type of game, and there's going to be multiple server nodes inside the cluster, and these are going to be a stateful set. So each one of them has their own specific part of the game world that they're calculating the location of things and how they're interacting with each other. And then they're going to be broadcasting their data through WebSocket to these proxy nodes. And these proxy nodes are going to decide which player clients need which part of the world so that we can save traffic over the internet, sending only the messages that each player needs. So what I'm going to do to achieve this is these proxy nodes are going to want to, once they wake up, once they're come online, they're going to reach out to every server node and say, hey, I'm ready to receive WebSocket messages from you concerning what's going on inside your part of the world. So they want to target each one of these server nodes. And we're going to achieve that using a headless service. And to set up a headless service, you'll need to just, in your headless service YAML file where you're configuring that you have a service, in the cluster IP field, you'll select none, or you'll type in none. Of course, you'll use the selector to target the type of pod you have, and the pods that I have are in a stateful set, so that they're going to get individual names that will be like stateful set -0 for the first one, stateful set -1 for the next one, and so on. And they'll just have a name that's easy to keep track of. In my example, I've got 2 replicas, so we'll have 2 of these server nodes, and this is how we're connecting them to the headless service. We just have the label is the same as what we're targeting here with the selector. And I also set some environment variables in here, so we're going to be able to know within our Node.js application the IP address of this pod and the pod name. Now, this is different than the DNS lookup. This is just for the pod to know its own IP address. It's not going to be how the client or the proxies are going to know the IP address. They know that through the DNS lookup. This is just from inside the pod itself. And we'll use these environment variables to be able to know, like inside the messages we're receiving, which one it came from, just for demonstration purposes, to show you that it will be coming from both of our replicas. Okay. And in the proxy nodes, we're just going to have a regular cluster IP. So when a client connects to a proxy, they'll just get load balanced to one of them randomly, which is okay. And then in our example, we just have one of these replicas. So we'll have one proxy node in our deployment here in our cluster and 2 server nodes. And this proxy node is going to DNS look up the headless service, get both of these IP addresses, and make WebSocket connections to both of them, and then these servers will broadcast messages. All right, so over in the proxy node, we know that we're getting the addresses through the DNS lookup. And remember, all we had to do is put in the name of the headless service, and we set all to true. Now, if we look at the Node.js docs, we'll see the DNS lookup function And it says when all is set to true, that's how you get the array with all the addresses. And if you did not set that to true, you would just get randomly one of the IP addresses that's behind that service, but we want all of them so we can connect to each one, however many there might be. And as we see, we console log them out, we do get both of them. And if we look into our deployment here, we do have 2 server nodes. And we do have the headless servers here. And you can see the cluster IP is none. Okay, so we don't just want the IP addresses, we actually want to connect to them. So what I'll do then is inside this callback, once I get the addresses, I'm going to loop through them, and then we're getting that object that has the address in the family. And then I just want the address. So I take that out and put it in the IP address variable here. And if that exists, we're going to connect to it. And we just put the IP address, and the protocol that I want in front of it is WebSocket because we're doing WebSocket connection. Now this function is a function that I declared above here. And what we do is we take our address that we've fed in, and we make a new WebSocket, which is going to try to connect. And on this WebSocket object, we have some event listeners that come by default. One of them is on open. So once the connection's made, if it's successful, we'll get this message out. That just says we connected and the IP address that we already passed in. And if we get a message, we're just going to console log the message data right there. So in our server node, what does that look like? Well, we create a WebSocket server. And I put client tracking true as an option. All that does is that this object now has a list of all the sockets that are connected to it. But there's only going to be one. There, feasibly, there might be a bunch of them in this example, but right now we're just using one. And when the server receives a connection, we get the socket that connected to it, and we're going to console log out a proxy connected to us, and we're going to log out our pod name, which we got from that environment variable that we declared in the container spec. And these are Kubernetes specific things that you can add as environment variables. So there's a few of them in the Kubernetes docs, you can find them, but this is just how you add them in. I'm just using the IP and the pod name. But there's a few other ones. That's pretty cool. All right, so then we'll send the proxy a message. Hey, you've connected to us. This is our pod name, this is our IP address. And then on an interval of every 4 seconds, we'll just send them a test message. And ideally, we should see, because we're console logging these messages over here, that on the proxy node, that we'll be getting messages from 2 different server nodes, and that they'll have 2 different names. Since we're sending, each one knows its own name, there should be a 0 and a 1. And here we can see, if I scroll up, you could probably see that the scroll bar is changing because every 4 seconds we're getting more messages. And indeed, we're getting test messages from stateful set 0 and stateful set 1. And the IP address is the IP address that got sent over through this environment variable. And we're just console logging that message directly here. It's just to clarify, again, that's different than the IP address that we looked up. I mean, it'll be the same number, but this is just the message that we're receiving. That was part of that message was we're sending the IP address. But the way we actually connected to it was we got the addresses from the DNS lookup from the Node DNS part of Node.js that includes the DNS lookup functionality. And that's how we initiated that connection from our proxy nodes to the server nodes. Cool. So that's basically it. That's how I was able to accomplish this. Hopefully this was able to help you, and thanks for watching. I'll see you next time. Goodbye.